Hello students. So in today's session we will be discussing about word count example in form of execution. That is how well you want to work out in a practical fashion. Yes, well, we had discussed about the Java program in another video where I've explained you what all things happen there, how exactly the flow takes place, which are the classes involved in that. Okay, so we'll be having a quick review about that first. So initially I'll be discussing about the program so that you can get a link towards it. So what we'll do here is, first we'll have the Java program, which will be once again discussed, what all points are required, what is important, okay, how exactly we write down a MapReduce task, what all things happen there, how the Java program is written, all those points will be discussed initially. Once we discuss that, I would like to make you understand one point here, that is, when we work out with a particular Hadoop framework, okay, you need to understand that everything is in Java implementation. Okay, first thing is that. Then when we talk about the Java, you need to compile the program, you need to get the class files, okay, and the class files are the one which will play a very important role. Okay, so basically here we'll be first discussing about the program, then the execution, how you do it in the command prompt, that is the Hadoop operations. Yes, so when we talk about the Hadoop operation, that is the time where I'll be discussing in detail about what and how you have to work with the compiling of the Java programs. Okay, so with that part of the things, we'll start off with the word count execution. Now as we say here, word count execution, we are trying to perform here the Java program and the MapReduce tasks. So we'll be focusing on these 2 points initially. So let's begin with the first, that is MapReduce program. What exactly it consists of? So so as we consider this MapReduce program, it consists of 3 following parts, that is the driver, that is the main, okay, that will trigger the map and reduce methods. So we'll be using the methods which will be performing the functionality, the operations of that. Okay, so that will be called by the or invoked by the driver main program. Next we have another part, that is the mapper. Okay, so when we talk about the mapper, we need to understand how the mapping takes place, what all things happen in that. Yes, you have to just associate what we have learnt in the MapReduce concept in this programming part of it. So when I say mapper, obviously you need to think about the data, what is to be taken as input, okay, what is the design pattern you want to work on it, yes, and how well you want to establish it, okay, the design pattern, so that it can be performed or it can be operated, okay, and it can be sent as an input to the reducer. Okay, so this is what is the point you have to understand initially with the driver, that is the main. Of course the mapper and the reducer are the main things which you need to focus. Now when we talk about this mapper, basically we are talking about the word count example. So we'll be taking up our statements in a file, okay, and we are trying to take each word in it and we are trying to work out in a proper format or a design pattern. So the design pattern, what you have to look out here is the one which tells how you are trying to work out and get the job done. Okay, now let us consider there is word count, means basically you are trying to understand a particular set of what you can say words or terms which are appearing, which are occurring, and all these occurrence have to be count, or you can say sum it up, and the counted values have to be generated. That is what is the word count you mean by, right? So how exactly we do it is the main task. Well, if I take a file, it is just for your understanding, where we have hardly any values, okay, but we are not talking on those part, okay, this is just for your understanding, a small thing, but on larger scale it's the huge amount of data. It's a voluminous data, huge voluminous data which has to be taken care of. Okay, so when I say huge amount of data and all those things. We will be talking on the data of Facebook. We talk about the data in Twitter. We talk on the data about weather forecast. We talk on the data about the stock exchange. Well, the examples go on. Yes? So you have to understand a simple program here. Okay, the concepts in that, and you have to implement on the following examples which are stated. Now, when you talk about all these examples, you can just imagine the amount of data is in zettabyte or petabyte. Okay, so that is what is the idea you have to look out for. Okay, so you have to generate a particular data, okay, wherein the mapper and reducer is working on it and the data is generated. Okay, well, when I say data is generated, it is a valued data. Okay, it is a data which is required, a data which is being utilized. So that is the idea you have to work it out with. Okay, so we have this driver, we have mapper, we have reducer. Okay, so it is better to include the map, reduce and main methods in 3 different classes. Okay, so that is what we are talking about. So we'll just learn how it is done one by one. So we have here the mapper. So in the mapper class, what we state here is public static class map extends map reduce base implements mapper. So we have here a class map, okay, which is extending, okay, so towards the map reduce base. So we are trying to inherit all the properties from this base class, and we have a mapper implementation, okay, which will be actually implementing all the tasks in it. So that is the mapper. Okay, so this is what you have to work out with. So the mapper is the implementer, which will be actually working out with the concept. Okay, next we have private final static int writable 1. So we are talking about this particular, well, I will not discuss about private final static. That is what you have learned in Java already. Well, we have to learn only about what? Int writable 1 is equal to new int writable. So int writable is basically the integer value which you want to write into that. Okay, what you need to work out with the data. Next is private text word. Okay, well, when you say stated as private or final, and this is basically focused only on this particular mapper. Okay, you cannot use it anywhere else. That is what is the point you have to work with. Next, we talk about the public void map. So when I say public void map, this is the method which will actually implement the tasks. So the arguments passed here is, there are almost 4, but the first 2 when we talk about is long writable key, okay, and text value. So basically we talk about the first thing, that is key value. So we are talking about a particular data which is to be considered in a key value pair. The key value pair is to be considered, and that has to be mapped, and that has to be processed. Okay, so long writable key, it may be a bigger one, we need to know, so it is a long writable, and values text, it may be anything, string, numbers, whatever it is considered as that. Next we have output collector and output. So output collector is another data type which will be having the output in it. Of course, the output collector is another property which will be holding certain values of that. Then we have the reporter. Of course, the reporter is the one which will report whether the mapping tasks are working properly or not. Okay, because when we talk about these concepts, we say that it's a mapper which will be helping us to know from where the input is taken. After the input, they are trying to splitting it, and then later they are trying to map it. Okay, so that is the concept which is happening in this particular part. So when you are trying to do this, it has to be monitored because it's happening in the nodes. Okay, so a particular data node is the one, there are multiple data nodes in which the task may be happening. There are slave nodes, and the name node is the one which will be keeping track of it. Yes, so that is what you learned in HDFS. In MapReduce, we talk it as a job tracker and task tracker. So the task tracker is the one which will be trying to implement it, and the job tracker will be trying to monitor it. So that is a reporter which will be reporting it. That is how it will be considered. So throws IO exception, of course, input output exception is there to check any exception handling concept. So once we do that, we are trying to get the input. So the mapper will try to take the input from a particular file. Okay, so here we are talking about a command line interface or a file arguments, what you want to pass to it. So in this arguments, we are passing the file itself and trying to perform. So string and line is the one which has to be considered. So is equal to value dot toString. So it will try to convert that into each values. Okay, the method which is there to toString, which will help us to consider each line of it. Okay, and try to consider as the value. Then in a line, if you consider a point here, that is a tokenizer. So string tokenizer is another data type which will be a keyword, sorry, not data type, it's a keyword and a tokenizer, so that we can tokenize each term in a particular statement. So the statement what you need to understand here is basically welcome to MapReduce or welcome to Hadoop. Let us consider these two statements. Welcome to Hadoop, welcome to MapReduce. What happens in that case? There are two statements. Okay, so how will you understand there are particular terms in that? Okay, so each word is tokenized. So that is why the tokenizer has been implemented. So new string tokenizer line. So the line is considered. In that line, you are trying to tokenize each and every word after a particular character. That is special character. That is a comma. That is it may be a space, white space, or blank space, new line. All these are the points which will be considered as the tokenizers. Okay. Next, what we need to do here is we have to consider the whole statement. So the statement is what? Welcome to Hadoop, welcome to MapReduce. So while tokenizer dot has more tokens, okay, so what happens in that case? We are trying to have an iteration. We are trying to consider from the beginning till the end. So word dot set. So you are trying to have a set method wherein tokenizer dot next token. So how many tokens are present in that? All are taken or considered into the particular word. So we are trying to take a particular argument, that is word, and the method set. So the set will be having all the tokens in that, and that will be assigned to the word value. Okay. So word is a part which is again used in the later, that is output dot collect. So we are trying to have a output dot collect method. So collect is a method which will be having two arguments, that is word and one. So word is having the set of tokens. So welcome to Hadoop, welcome to MapReduce. Okay, so in short there are 6 tokens. All 6 tokens are to be considered, and all these are words which are placed. Okay, so word will be having all those, comma 1. What is 1? 1 is basically the iteration part of it. Okay, now this is what is the key value pair which has been taken care. What is happening here? Word is all those 6 terms, comma 1 is the value. It may be appearing for 1 or it may be appearing more than 1, and that is what is the point you have to consider. Okay, so this is the point you have to work with the mapper. So once we do with the mapper, the next point is basically we have described this. This explanation is there for you to understand. Once again you can go through it. Okay, what all things happen here. Okay, each and every part is explained, and you can just have a glance here. So the detail is mentioned. I would like to move on with the example, that is implements mapper. Okay, so interface mapper. So we have an interface here, the mapper, which will actually connect the input file, okay, which will be the actual data which will be considered, and we move on. So there are 2 points which you need to understand here. So it has the map method. How exactly the interface has been mapped? Okay, you can see here it is K1V1 and K2V2. So K1V1 will be the input taken by the file, okay, and that will be processed in the mapper part of it in a particular design pattern, in a particular algorithm. Yes. Next, K2V2 will be the output. That is what is mentioned here. So first pair is the input key value pair, and second is the output key value pair. Okay, so that this output becomes the input for the reduction or the reducer program. So long writable, text, and writable, what is the definition, and all these are given here. So these are all the data types provided here as a Hadoop specific data types. Okay, so long writable, int writable, all these are having similar definition, but these are mentioned or specific towards the Hadoop specific data type designed for operational efficiency, suited for massive parallel and lightning read write operation. Okay, so fast read write operation is to be done, so that is why the operations, the data types have been made it specific with a particular term as long writable and int writable. Okay, well the definition will remain same, which is integer and long. Okay, next we have all these data types are based out of Java. That is what I said. So a long writable is equivalent to the long in Java, and int writable for int, and text for string in Java. That is what is the main or identical part of it. Okay, that is all about the mapper. So you have a particular program here, which is mapper part of it. So for private final static int writable one, this is how you write it: public void map output collector. So you are trying to mention it in a programming concept. So data type of the input key of and the value to the mapper is key and value. Okay, so K and V are the particular collected data output by either the mapper or the reducer, that is intermediate output or the output of the job. Okay, so K and V are the output key and value for the mapper is example. Here they are given double quote, that is the comma 1. So here I said as welcome to Hadoop, welcome to MapReduce. So welcome to, so welcome is 1. That is all the particular. So reporter is used to report the task status internally in Hadoop environment to avoid timeouts. Whether the node is working properly, active or inactive, those things have to be taken care. So this is further explained with all the details, that is what exactly the tokenizer is. So tokenizer is to split the lines. That's what the next function is in the MapReduce concept. Okay, so when you take the input from the client, it goes to a particular split. That is where you are trying to have a particular design pattern, right? So you are trying to understand that this is the word count. So you need to understand each and every word. So the tokenizer is the one which will help you to work with that. Okay, so the string line is basically the input line in text type to a string. So it is considered a string, and it has to be worked out in that fashion. So iterate through each word and form a key value pair. That is what the while statement, okay, while condition is trying to perform. And output collect is the one which will be having a particular data which has to be pushed into the reduce part of it, or combiner. Okay, that is the intermediate part of it. So the reducer is here. So class header similar to the one in map, similar because you have to accept the key value pair of that concept. The text int writable is there. So reduce header similar to the one in map with different key value data types. That is what is the point. So data from map will be word, and the value will be in a set. Why set? Because a word may be appearing more than one. Okay, so it's an iterated value. So that is why it is taken as a set of value. So we get it with an iterator, so we can go through the set of values. Okay, so word is the key and the value is basically the set of values. Okay, so the reduce will be having text, key, then iterator, iterable values, that is the iteration part. It will be iterated and then finalized. Then we have the output collector, which will be having the output part of it, which is the word, that is the text, and the value, which is the int. Okay, the count of the words. So that is output. Then the reporter, of course, to keep track of the internal environment. Then what is the next thing you have to do in the reducer is you have to aggregate it. Okay, you have to get all the things at once. What is that? You have the particular key, that is the word. Okay, you have the set of values, you have to combine that. Okay, you have to sum it up so that you can get the actual count of a particular word. Yes? So what is happening here? You have to just implement a simple concept, that is sum. You have to get the count of all words. So how will you do it? You have to just go on adding it, and that is how you have to work with the sum of it. So I will be starting with initializing the sum. Okay, then iterate through all the values with respect to a key and sum up all of them. So value dot has next. So this is a particular method in the while function which is used to get all the values which are there in the iteration, and we are just trying to get until the last value which is there. Okay, so this is how the iteration works. Has next, it will point towards the next value and goes on until there is end of file. Okay, once it comes end of file, so what happens? Sum plus equal to values dot next, whatever is the value in that, dot get. So these methods will actually get the values and will take the sum of it. So in short, it will be having, if there are more number of words, it will go on adding those numbers and the sum of that particular value will be stored, and if there is next value anything in that, it will try to keep it, and if it is there, you will get that particular value, and if it is end of file, just come out of the while method. Okay, and what happens next is push to the output collector the key and the obtained sum as values. So basically when we talk about that concept here, what happens is, I told you that we'll be using the particular term that is welcome to Hadoop, and next line, welcome to map reduce. Okay, so what is happening here? Initially we take each of these particular terms, we need to take this as a string. Okay, as a string, welcome to Hadoop, welcome to map reduce. This is on the next line. Okay, then we apply the tokenizer to the welcome to Hadoop. Next line we go again, welcome to map reduce. So what happens in the mapper part of it? In the mapper class, we have welcome, which will be in the form of how many? 1, comma, or you can say dot. So that is how the value is there. Okay, 1. Again, it goes through this set of values. Okay, it is an iteration, right? In the mapper, it checks welcome, the token, next token, then the Hadoop is next one. Then again, welcome is there. Okay. So I get one more part of it. Of course, this is the first thing, and this is the next one. Okay, which is in the flower bracket. Okay, just remember that it's in a flower bracket. That's the end of it. We close it because it has appeared only twice. Next, what happens here is we go to 2. Again, we have yes 2. Okay, comma, what happens, we have a value set here, again set of values. So 2, it goes to Hadoop, welcome, again it comes 2. So what happens, we get first one, comma, second one, and after that again it goes, it says there is nothing more in that. We close it and close the particular bracket. Okay, so welcome to, similarly we have Hadoop and MapReduce. So how does the Hadoop and MapReduce work out? Well, it will be only once. Hadoop will be 1, similarly MapReduce. Okay, so this is how you get the concept about that. So what it says, you are trying to have this whole set of values and you are trying to send it to the reducer. So in the reducer, what happens, we are just trying to collect that text verification. So this is the input to the reducer. These all set are the input to the reducer. So we'll be considering welcome. So what happens in that welcome? Of course, we have here welcome. Okay. So the iterated value, how many it has? It has next, it will check 1, 1. So it will be 2. And that is how it will complete that. Next, it will be 2, that is TO, and here again we'll be having 2. Next we have Hadoop, okay, which will be having 1, and similarly map reduce, okay, which will be also 1. So basically this is how the word count will be considered and the result will be displayed. So this is what happens in the following set of program. Okay, this is how it works. So output.collect is the one which will actually consist of the following format, that is key, that is the word, and int writable sum. So the sum of that, so 1, 1, 2. 2 will be having again 1, 1, 2. Hadoop is 1, MapReduce is 1, so 1, 1. This is how the whole concept will be done with the reducer. Okay, so this is what happens with the reducer part of it. Then the main function in which we need to focus on the job conf object. So this is a particular job conf object which will be helping us to perform the whole concept. Okay, so it will tell what kind of data pattern or design pattern is to be considered. Okay, when I say here, it's a word count. So basically, it will be having the idea about there is a word. Okay, that is the key, and a value which will be having the number of values. Number of time it has appeared. So that is the particular object of that objective of that object, that is the job conf. So it is the primary interface for a user to describe a map reduce job to the Hadoop framework for execution, such as what map and reduce classes to use and the format of the input and output files. So that is the idea, right? So job conf is the one which will actually tell the whole Java program to understand that it's a key value pair which has to be implemented. So its input is key value pair and output is also key value pair. In that format, it has to work out the primary interface. Okay, so the other things will be managed by it. So we'll just go through the main part of it. Okay, so here the description is there. You can go through this description also. You can understand what is the details about that particular program. Okay, so this is the program job conf. Conf is the object which has been created. So word count dot class is the one which will be fetched from that. So conf dot set job name word count. So that is the idea. You are talking about the word, and after that you are trying to set the configuration object with the data type of output key value. Okay, for map and reduce, if you have different type of outputs, there is other set method for them. So here right now we'll be using set output key class, set output value class. Okay, so that is how you are trying to divide it. You are trying to consider one as a text, that is the key class. Okay, and next is the value class which will be having the int writable part of it. So this is how you are trying to define the each and every details of it. That makes it very simple now, right? So you are having a class which will be having all the keys, and another will be having the values, and based on that you are trying to map it and work it out. Okay, of course when you try to do this at the end, this is where the shuffling and sorting happens, and then you give the result. Okay, so this is what is the idea. So when we get these two classes, what next we have to do is you have to just sort and shuffle, and you will get the data, and that is what happens at the background when we use the mapper and the reducer class itself. Okay, so next is what? Providing the mapper and reducer class names, that is map.class, reduce.class, and the set mapper class, set combiner class. Okay, so set reducer class, the combiner is the one which will combine the input from the particular, that is mapper class, and it will be providing to the reducer class as the input. Okay, so the output from the mapper will be taken into a combiner, and the combiner take that output as the input to the reducer. This is what happens here. Okay, so the default input format is text input format. Will load data in as long writable text pair. Okay, so the long value is the byte offset of the line in the file. That is what is the point you have to make a note of. So set input and output format so that it is known to it. Okay, because here we are talking with the HDFS part of it. You are not gonna have direct, you not be able to know it manually. You cannot do anything in that. Okay. You have to just set, you have to work with the HDFS part just to store the data, right? But how it works, what all things are there in it, if you want to work, it won't be possible. Okay, so that is all maintained in this particular format, so that it is clearly defined how the set input format and set output format has been taken care. Last is what? Set input path and set output path, where you are trying to pass the path, that is by arguments. Okay. So the arguments have been passed, either you will be passing it through the command line or you are trying to pass it through the files. That is what is the point you have to keep. And last is to run the job conf. Okay, so this is all about the programming part which you need to understand. Okay, so the next part what I will be discussing will be the Hadoop operations which you need to do. Okay, which you need to sit and do it and execute the whole part of it. Okay, so we'll just go with that now. Okay, so this particular section will tell you that once the program is being compiled in the Eclipse IDE, okay, so the Eclipse program, how you have to do it and all, the Java files, everything is being provided in the PPT to you. Okay, you can just go through that. Now, what happens next is, once you are trying to execute that, compile it, you get a class file after compiling, right? So that particular file has to be taken as a jar file, because you're having, this is how you have to work out with that, because you're having more than 2-3 classes which have been taken care. There is a mapper class, there is a reducer class, there are 2 reduce classes, right? Okay, the main class also. So all these 3 will be considered, and you have to take it into a jar file. All these are to be taken into a jar file, and then only you can perform it. Okay, now this program is written fine. Now we'll talk about actually how the data has to be taken care of, how the file is sent into that, how it is processed, and how you'll get the output. Okay, so with that, the first one, you have to open up the command prompt in administrative mode, and you have to type the path, that is c:/hadoop/sbin, and you have to start the cluster. Okay, it's a single node cluster which is established when you install this particular part of it. Okay, when it's in a video I have spoken about the Hadoop installation, you can work out with that. Now after that, you have to work with the start all CMD. Okay, just make a small point here. It's not that it's a small one. Hope you understand why the necessary changes have been done here, because it's a main motive to understand that it's a small case. Okay, start -all.cmd. Once I hit that, what is the next point I get is this. So you can see here the window command prompt is there, where I have gone into the administrative mode. 3 windows, I come out of that, cd Hadoop 2.8.0 has been, and there I type start -all.cmd. When I type that, I get all these different windows. Well, why these windows are necessary? Because these are the main concept which is working with the Hadoop framework, that is the MapReduce framework. Okay, that is name node, data node, resource manager of yarn, and yarn node manager. Okay, so these all particular points are very important for us to implement. So all these windows, you can let them minimize it and let them work on the background. Go back to the command prompt, and in the command prompt you need to start working with the particular points. Okay, so this is one thing you have to make a note of. Next, what you have to do here is, after you get this concept, okay, you can create an input directory in HDFS, that is Hadoop fs-input_dir. Okay, now this is what is the point you have to make a note of. This is what the file management system in that command I already come across. So Hadoop fs-mkdir is the one which will help you to create the directory, and the directory name is input_dir. Okay, now the next step is what? You need to first have a file, existing file, okay, local, in a local system, so that you can work on it, right? You cannot have it directly on the HDFS, you cannot create there. Okay, human intervention is not there with HDFS. Only through command you have to just send it, and that is how the data will be taken care. Okay, you cannot do anything there. So what happens here? Copy the input text file named input_file.txt. This has to be created initially with some value or data present in that file. So a text file is created, okay, and you are trying to use a particular command which will be sending it into or copying it to the HDFS. So Hadoop fs-put the local system path, that is a c::input file text, that is /input_dir. So this particular file from the C drive will be copied to the input directory of the HDFS. This is what happens with the following command. Next, what we have here is, of course, you're trying to verify whether it is there. You are trying to use a list. Okay. Now, before we go with the listing, you have to type one more thing, that is JPS. Okay. Now, why JPS? Because we are to understand whether the Hadoop is installed properly. Okay. All the particular windows what is opened, it has a process ID. Okay. So that is what is being showed here. So Java process status with all the node manager, data node, name node, and resource manager will be provided. So once you get this JPS, it's like thumbs up to go ahead with the particular programming concept. You can go on with the commands, you can execute anything because it is successfully installed in your system. Okay, that is what is the point. Now, Next, what you need to do here is to just work with the listing of file. Okay, that is what I told you. So ls hyphen ls input is there. So two files are there which will be found. There are two items. So admin, because they have the in administrative mode, super group because it's a single node cluster and you are the super group of it, because you are trying to create a single node cluster in that, where you have the client and server both in one. So you get the super group in that, and these are the particular points which have been created. Okay, so the file one text and input underscore file dot text is one which has been created. Okay, so get the aggregate length of that. So one is having 84, another one is having 1888. That is the length of that particular file. So we'll be working on this particular input underscore file dot text, wherein we have 1888 values, okay, or data in that particular file, and how it has been implemented. Okay, so the date is there when this particular program was done, okay, long back, and the time also. So this is what will be the point. Next is, what are the contents? So I told you that we are having the length of the file is 1888, that is 1888. So what it may be consisting of? Are those so many words which are there? Well, we have considered here as a text. It may be words, it may be numbers. So here I have taken the numbers, so you'll just see what are the contents. Hadoop dfs-cat, okay, and the path, so that we can see where it is. So this is how you can see the idea, how it is taken in that. Start, I have given a screenshot here, start hyphen all, JPS, then the list of input, then I have taken the input, what are the contents, using the hyphen cat. So the cat command will help you to do. So I have taken here numbers. So each number is considered as a text or the key. Okay, so key is so here it is word 23 is, so we have taken a set of words which are repeated, so that becomes much more easy to work on it. So okay, so you have a list of keys here, right, from 23 up to 45, that is the maximum number. Okay, so what happens here, we have to just count how many times each of these keys are repeated. That is what is the word count, right? Yes, so each of these are particularly considered. Word count is to be the pattern, and you are trying to see here the tokenizer. We are having all the spaces and the next line in which the file is being created. Okay, so you can just go on typing from 23 to 45. There is a range in which all these terms are considered. Okay, so let us have a range so that it becomes easy for you to also understand. You are not taking any numbers. Okay, you have taken a particular range of numbers from 23 to 45. In between that, we have repeated these numbers. Okay, so that is what is the point you have to make a note of. Okay, so this is the input file. This is what the contents which are there in it. So you can see here, that is what, so it's such a huge, that's why the length of the file was 1888. Okay, so it was 1888 length of the file. That is the amount of values which are present in this particular file. Okay, the data what is there in this. Okay, the keys. So we have to process that, and you have to just find from 23 to 45 how many times each number has been appeared, whichever number has been listed here. Okay, so the range is 23 to 45. That is what the part is. Now, what happens next, I told you, is after this particular step, you have to go back to the particular file, that is the class files, which have been generated after the compiling of it. Once you compile, you get the main class, the reducer, and the mapper class. All these are considered into a, or taken into a jar file. Okay, so once this jar file is considered, that jar file is named as MapReduce client. Okay, so MapReduce client is the one which is taken. That jar file will be executed, not the all class files. Okay, that is what the Hadoop framework does. It takes as many number of classes into a jar file, and it can work out with it. Okay, now, so Hadoop space jar space the path, that is C colon MapReduce client the jar, and the program name, that is word count, space the HDFS part of it, which is having input, okay, slash output 1. Okay, now this is what is the point you have to make a note of. What is that? Of course, I have made a small change here. Here I have taken as an output 1, but in the next one it is output underscore directory. Okay, so I just while copying, I just did not edit it, but it's the same. Okay, don't make any confusion in that. output 1 or output underscore directory. It's almost the same. I've just made the name change in that, nothing else. Okay, so you can use either of it and you can work out for that. Now, once what you do is, when we run this particular command, you can also provide the input file directory and the output directory. So the executed data will be in a particular directory. It will be in the directory and you have to check in the directory how it has been stored. You cannot get it manually. No, there's no file where you can just go to the HDFS and click. No, that's what I say. You cannot, the human intervention is not there to the HDFS. Okay, so you have to create a directory. From directory you can fetch it and display it. Okay, so keep that in mind. One thing, that is this name, and the other one is where exactly you can get the result, that is the output part of it. Okay, now once I enter this particular part, it will give me all the details. Okay, each and every details of the file that is to be taken care. Okay, so the number of large read operations, number of write operations, bytes read or written, read operations, number of large read operations. Okay, all these are done with the file and HDFS. Okay. Next, what you get, the job counters, where it will tell which are the map tasks, which are the reduced tasks. Of course, there is one, only one file is there, so it will be working on one file. Okay, so what is the time spent? Okay, how much slots are there? What are the milliseconds which are taken by each of them to complete it? Okay, so all those details will be provided here when you execute that command. Okay, so we get all these details about the map task, reduce task. Okay, after that what you do is map reduce framework. So here it gives you the details about that, like map input record is equal to 30, map output record is equal to 390, map output bytes is equal to 2730. Okay, and the materialized bytes. All these are the internal parts which will be displayed here and how it is implementing it. Okay, so input split byte is 111. So all these details are provided. You can just go through them one by one. Yes, because it's the internal part, you have to just have a idea about it. You are not working on that. It's the point which is to be taken care. Okay, once these all things are there, it is actually working properly in that. Okay, the whole concept, what you learned in HDFS, what you learned in MapReduce, everything is stated here in a practical part of it. Okay, so we have what you call as merged map output. That is where you talk about the sorting and shuffling part, the merging part, then the physical memory, virtual memory used, so and the total committed heap usage. Each and every details have been generated, which is to be taken. Then shuffle errors. If you find any, it will give you 1, else it is all 0, so no problem. Then the last part of it, that is where actually the whole part you have to understand, that is a file input format counter. So in the program also you had a file input format, right? So that and the file output format, both have to be taken care. So bytes read is 1888, whereas bytes written is 120. Okay, so you are trying to have the reducer implemented here, because there are 1888 numbers. Okay, what that is the length of that with all the details in it. Okay, all of them are taken as key and the value, how many times they have repeated and the count, and that is coming down to 120. Okay, that is what is the point you have to make note of it. Okay, so once you get this, this is how the output will be taken care. So I have given a command here, that is Hadoop DFS -cat and / output 1 also you can write down if you have created output 1, or output underscore directory / asterisk. Okay, whatever data is there in that, everything will be displayed in this. So all this is working with respect to Windows 10. Okay, so with respect to Windows, this is execution which is happening. Of course, you can do it in Ubuntu also or CentOS, but that is a different scenario. We are trying to focus only on Windows, and that is how it has been implemented. So this is how you are trying to get the result. So you can see here from 23 to 45 it is sorted, and each particular key, that is 23, 24, 25, whatever the keys are there and the values which are there for it, how many times it has occurred, you can get the details. Okay, so in that case what happens, you can see the largest is what, that is 39 is the key which has occurred 66 times. Okay, so this is how you can just find out how it has been taken care. Okay, so what happens here, this is the key and this is the value. So these are the words and these are the number of occurrences which are. So 23 has occurred 12 times, that is the word count. Okay, so this becomes much more easier to make. If you take a particular welcome to Hadoop or welcome to MapReduce, you will be getting what the answer is that welcome, it will be 2, TO will be 2, Hadoop will be 1, MapReduce will be 1. So that is a very small one, okay, data. So I have taken a huge one which is almost 1,888 of it, and 120 is the part of it. So this is what all things you need to understand and go ahead with this. So please practice this. I hope whatever I have tried here is conveyed. If you have any doubts, any particular query, please feel free to ask. Okay, post on our group, and we are here to help you out so that these things are done by you. Okay, so try and do it. All the best. Take care. Thank you.